Right, g'day guys. This is a question for B Block, otherwise known as grade 11. We're going to be going over interpenetration and development drawing. And we're going to go through nice and slowly from start to end. I'm not going to be making a series of small videos. It's going to be one long video. You are welcome to obviously skip to the views that you want to, or the process, or part of the drawing that you feel you need to go to. But anyway, let's read it together and let's get cracking. So what is given? The drawing below shows the complete top view as well as the incomplete front view of a square pipe. So there's our square pipe, right? Which has been penetrated by a hexagonal duct. So there's your hexagonal duct that is penetrating, as you'll see, at right angles. So it's coming in at right angles to penetrate the square duct. So an auxiliary view of the hexagonal duct is shown in the top view. Because of the way it's laid out, you don't need a auxiliary for the top view. I'll show you why just now. As you get onto more complex interpens, as you move into grade 12 or A block, you will need that. Right, so what is given? Point S has been given as a reference to start the top view, and then point P has been given as a reference to start the auxiliary view for the front view. Okay, and then what do we need to draw? The top view, front view, and right side view, showing the curve of interpenetration, and then, or the line of interpenetration. There wouldn't be much of a curve because there's no cylinder here. The development of the rectangular faces of the hexagonal duct would show the curve of the interpen. Okay, so let's do that. Show all constructions as well. So we need to show that, because if you do something wrong but your constructions are evident, then we can mark you for consistency. Okay, so let's get going. So because I've been given a square and I've been given the length of one side, I can then use my circumscribed method, which means I can take my compass, I can open up to a total of 50, so not 50, 25. Why do we open up to 25? 25 is the radius we need to work with, because we're going to draw a circle with a diameter of 50. So on S, all right, I'm going to draw a circle with a diameter of 50, which means I'm working with a radius of 25. Once I've scribed that in, I'm going to take my 45-degree set square, and as you'll see, we're going to be working with 45s to complete this the square the square pipe. So I'm going to use green here, and I'm going to run tangentials, which means I'm going to run a line just touching the circumference of the circle there, on the left and on the right here. You'll see just touching. I'm going to do that this way as well, towards the left. Okay, top and bottom, or left and right. Okay, there we go. So there is my square duct, and then I don't think I'm going to need a center marking right now. I'm going to draw that in green. So my square duct is going to be in green, and I'll draw it in an outline in green. So now, the thing is here, obviously you won't be drawing in color, but for the sake of annotating and giving some clarity in the video and showing some differentiation, I'll be using a bit of color. Right, so a little bit of baby powder to get rid of all the smudging, or talcum powder as they call it. Talcum, there we go. Right, now we can start with the hexagonal pipe. So we are, hexagonal duct. But before we do that, I want to go ahead and construct the auxiliary. So I'm going to come up to the top here. We cannot draw this without the auxiliary. We need the dimensions and the true lengths in order to set it up so that we can draw the auxiliary. You'll see what I mean by that. So to draw a hexagon, the length of one side, and we're going to use the inscribed method. So we're going to go 30 millimeters. All right. 30 millimeters is what we're going to open up. So the circle in which all 6 points sit inscribed is going to be 30. We don't ever change now our compass at 30. So oopsie, I came off the point P there. You'll see I'm on there, and then I slowly come off. Right. Compasses are not perfect. Right, so there we go. Now what I'm going to do is I'm going to extend a little bit of an axis up and down. I'm going to use blue for my, I'm going to use blue for my hexagon. A little bit of an axis up and down. And I'll show you why I do this. The vertical one I didn't need, but I'm going to just show you. Right, there we go. So you'll see that those 2 points will essentially meet on our x-axis. So now I've got a point in which to arc from. So I'm going to arc 30 above, quickly 30 below, I'm going to go to the right hand side on that point, arc 30 above, arc 30 below, and here I can go ahead and I can join these points to create my my hexagon, sorry, which will be the auxiliary for my hexagonal duct. Okay, so there we go. There it is. Okay. There we go. All right. So unfortunately, there isn't a dimension in here, right, for the distance away. So I'm just going to multiply this by 2. So I've got 25 there. All right. So let's work with 25. So I'm going to come off a distance of 25 first. So I'm going to just extend that a little bit. Okay. I'm going to work off a distance of 25. There it is. 25 is there. Okay. So what I'll do now is draw a line. Right, that's going to be the base edge of my hexagon. So that's going to be the base, and then obviously we're going to move and penetrate from there on. Okay, so how am I going to do this? Right, so what I'll do is to get the total length of the hexagon from point, which would be that point over there, okay, all the way across to this point over here, which is going to be that point over there. This needs you need a bit of conceptualization to sort of work that one out, but you can see those 2 points will be on the top, nice and high. So that total distance from there to there, so let me just annotate this from you, from there to there, right, is going to be, that distance there is going to be that distance over there. Okay, so whatever that distance is here, you can work that out, you can measure it, okay, or alternatively, you can open up your compass, and we can go that distance, which is that radius of 30, as we had earlier, so we can go 30 this way, 30 this way, right, and we can start to project in from there. So we're going to go, okay, termination point and a termination point from there, because we're following the given, right. Then we want this distance at the top. So this distance here is also going to be what? 30. So we're going to go 15 from the left and 15 from the right. So center up like that, and we're going to go 15 to the left and 15 to the right, or up and down. Then we're going to terminate with that. Terminate there, and terminate there. Right. Now what I'm going to do is, right, I'm going to go label this. So we're going to say that's 1, 2, 3, 4, 5, and 6. And if we bring those labels here, essentially what we have here is 1, 2, so 1, 2, yes, then 3, back to 4, then 5, and then back to 6 here, just so you have an idea. So then we know that's 3 is 3, that's 2 and 4, that's 1 and 5, and that's 6. Now what's important to do before you develop anything else is to figure out the turning point positioning. We need to take this turning point here. Now remember, these are termination points. Termination points, the seam, okay, of the hexagonal duct meets the surface of the triangle, of the square pipe. That is our termination point. So let me just give you a bit of an annotation there. That's a termination point. Right. This here is a turning point. I'm going to give you another annotation. So that's a turning point. So we have a turning point that's going to penetrate between 1 and 2 and between 4 and 5. So at the top, and not penetrate, sorry, it's going to cause material to turn around it between 1 and 2, and then at the bottom between 5 and 4, or 4 and 5. Okay, so what I need to do now is I need to bring that back onto to figure out where it's going to sit on my hexagonal duct in terms of its distances or its position in relation to all the 6 points. And you can see it strikes directly in the middle between 1 and 2. So it's going to be there and at the bottom over there. So I'm going to add that in. I'm going to put T for the top turning point and T for the bottom turning point. So you can see where it is going to be between 1 and 2 and 5 and 4. Between 1 and 2, 5 and 4, directly in the middle. That's my turning point. Okay. So what I'll do now is I'm going to project up. Right. So there we go. Project up, there, and there, and there. Okay? Good. And then we're going to work with a 20 mil margin up from there. So 20 to an axis, 10 to the axis, 10 to the margin. So we go 10 and 10. Okay, there it is. So that will be the base. These will be the base edges of the square pipe. Right, now we can go ahead and start to develop the the curve. And how we're going to do that, right, is to send, right, the termination points up as a projection. So we're going to take 3 up. Watch there, there's 3. All right, and I'm going to bring 3 across. So 3 sits there. I'm going to bring 3 across over there. So there it is. There's 3. Right. Then I'm going to take, well, 3 and 6 are on the same plane. So look, 3 and 6 sit on the same plane. So what I'm going to do there is make sure that, well, I bring 6 across, and so you can see that it meets on the same point. Right, then I'm going to be taking 1 and 2 up. They are on the same point. So 1 and 2 go up. Let me just illustrate this with. Okay, it doesn't line up as perfectly, so I'll just leave it. Right, there we go. So I'm going to bring 2 and 4. So that projection I've just done now, sorry guys, is 1 and 2 and 5 and 4. They sit on the same points. Okay, so I've projected them up. So therefore, look, if I bring 1 and 2 across, there we go. And if I bring 5 and 4 across, which also happens to be the turning point as well. Okay, there we go. Okay, so that turning point would sit there. Right, there we go. Then what I'll do is I'll bring up the distance. It's the base edge on which that hexagonal duct starts. Right, so there it is. So now what do? I can go join these seams to their termination points. 6 and 5 will end there, and 1 and 2 will start on the base edge there and hit there. What I'll do with those now is join them up. Now we've got the curve. This is the front view. There we go, front view. Almost done. Okay? So remember, that's 1 and 2, right? And obviously the turning point is there. Then that's 3 and 6, and that's 4 and 5. Okay. It's 10 above, so we're going to go 10 above. There it is. I'm going to get my green back out because we're working with the square duct, so 10 above, so about there. I'll bring that across. I can now commit to this and outline. There we go. Bring that straight down. I don't think we're going to have any hidden detail, so that's nice. It doesn't quite meet on the seam. You can see what we're trying to fill out here and outline is as if we were looking from the square duct in that direction. So we're going to have this point, and that point visible. However, that point is going to go until it comes into contact with the surface of 1 and 2, and then obviously off the bottom until it comes in contact to the surface of 4 and 5, where it'll turn on that point and that point. Rightio, there we go. Okay, so that's the front view done. Right, a little bit more powder. It's getting a bit dirty on this page. There we go. All right. Okay, so I'm going to set up an axis. I'm going to go 10 and 10. Let's get an axis and a margin going here. So obviously that will be my margin there. That will be my margin over here. Okay. Now we're going to go 10 off those to an axis. There we go, there's a 10. We're going to go 10 down from there. Okay, here we are. Okay, that's my axis. And that's my XY, and that's my XY, Y1. Right, and then we need our 45 deflector off that, but let's go get one more set of margins in. We need to work within that 10 there, so we're going to go 10 there. We're going to come down 10 over here. You guys know this process by now, that's why I'm not over-explaining it, and obviously that should meet, there we go, with the starting point of that duct. And then we've got now, there we go, margin there, and a margin over there. Right, 45 degree, a perpendicular, what I call deflector, so we're going to come off where the axis intersects. So we've got X, we've got Y, we've got X1, and we've got Y1 down the bottom here. Okay, remember to label it that way. Then, with our 45 degree, which is going to be used for our deflection. So I'm going to take green across, I'm going to take green across, and green across from there, which is on the margin, so I don't have to worry. And I'm projecting all these points up now into this quadrant. Remember, this is we're going to be doing the right side view, and it's first angle, so the right side view is always drawn on the left. Okay, remember that. Right is on the left is on the right. Okay, extend that a little bit. There we go. Bring the total height across. There we have it. Good. Then I'm going to take across my turning points. So now I'm going to work with my blue, and you can see how these are all going to match up. So we're going to bring 3 across from there. Actually didn't go get this in outliner. I need to add some outline to this duct at the bottom. So 3 across, 4 across, 2 and 4 across, sorry. Okay. 1 and 5 across. There we go. And we're going to bring 6 across. Make sure that's also nice and outlined. There we go. And then those we send straight up. Okay, there we go. Make sure this page is set nicely. There we go. 1. I'll send those all up. You can send up and then come across, send up, come across, or you can just do what I'm doing right now, which is just to send all of them up, right? And then you can annotate. So for example, that's 6. I know that 6 is going to be on there. I know that 1 and 5 are going to be on that projection. If you struggle, annotate. Annotation is your friend. Right, 2 and 4, and then 3 over there. Right, so they're going to be along there. So if I bring 4 and 5 across, there's 4 and 5's projection. So 4 and 5 are going to be there. Right, there's 3 and 6. I'm going to bring 3 and 6 across. There's 3. Right, there's 6 over there. And then obviously 1 and 2. 1 and 2 sit on the same as 1 and 5, so those lines that are in the middle. There we go. We don't need to bring the turning point across because the turning point is going to hit that face anyway, so you'll see what I mean. Right, there we go. So now I can join these up. And this should essentially look exactly like the auxiliary because it's all true length. So there it is. Right. There we go. Hexagon in. Now it's a matter of getting the outline for the square pipe. So it's a little bit closer on that side than this side. So a little bit of measurements off, but it's a little bit of board leniency. It's okay. Across the top. Also, I'm using quite a thick pen here as well, pencil. Let me get this outline in over here. Right, and then this seam will go until it comes into contact with that surface, and that seam will go until it comes into contact with that surface. And then I think we've got 1 and 5. Sorry, that's not a seam. I'll lie. Let me rub that out. That's not a seam. That's our turning point. That's a flat surface. You'll see. No, I'm wrong. That is a seam. I'm thinking I'm drawing a hexagon. That is the seam. Have a look here. The seam of the turning point, the seam that creates a turning point. We bring that across. It turns there, stops. Comes down from there, turns there, and stops. There we go. So that's all done. Next thing we need to do is construct the hexagonal duct in the development. So what I do when I develop, obviously I'm using blue now because we're going back to the hexagon, is I just set up an X and Y axis here. So X, okay, and a Y. Just nice and light construction. Then what I'm going to do here is, because I'm developing the hexagon, I'm going to have 6 faces. So I'm going to come to my auxiliary, open up to the distance of one face, which is going to be 30, obviously, and then I'm going to chase my arc 30 times. Call it chasing my arc. 1, 2, 3, 4, 5, and 6. There it is. Right. Ruler in place. And now what I'm going to do is just send up 6 seams. Okay? 6 seams. Nice construction. I usually go get the maximum height before I do this, but I'll show you what I mean by that. Right, so let's just say that that's, we'll start here with 1. So 1, 2, 3, 4, 5, and 6. Back to 1. Remember, whatever you start with, you should always end with. Oh, sorry, I haven't had that on the screen. Anyway, whatever you start with, you should end with. Now we need to go and get the true lengths of each of those seams. Okay, and we're going to now have to include the turning point. Right. So what I do is I set the total height, which is going to be the longest point, which is going to be either 3 or 6, or the longest termination edge. So I'm going to take this, which is 6, or the same as 3, and I'm going to go add it in. So that's not obviously the distance of 1, but that's how far it will go. Which what I'm going to do there then is when I get to watch the distance of which was 6 and 3. If when I get to 3, I'm just going to make a bigger mark, and when I get across to 6, I'm going to make a bigger mark. So now what's nice is you know that everything has to fit inside that. If it doesn't fit inside that framework, then you know you've gone beyond the parameters, bearing in mind that you've done that correctly. Okay, so now next thing I'm going to do is go grab the distances here. So this is going, I've done 6 and 3, I'm going to do 1 and 5. Okay, that's the true length of 1 and 5. Then I'm going to get 2 and 4, which is exactly the same length. Okay, 2 and 4. So now I just make a slightly darker annotation there, 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 and there, just so that you can see we've got everything we need. So hold on, and I need to pull 1 all the way across again because I end with 1, so I need the same height across there. Okay, so we're going to go there to there to there. We're going to join those up. However, we're not done yet. We need to add one more thing into the path here. Now you can see between 1 and 2 and 5 and 4 we're going to have that turning point, right? And you know that it's halfway in between. So if I come down to 1, 2, 4 and 5, and I'm just going to measure, I'm going to take 15 here, or even do this, come here, take that distance because that is a true length. Okay, between 1 and 2. So that now is between 1 and, so let's work with between 1 and 2. There we go. And now let's go work with between 4 and 5. There we go. So that's going to be my turning point. So what I'll do now is I'll use a bit of green to annotate that. So if we send that up, and we send that up, somewhere along there, we're going to have the height for that. Well, where do we get that height? Well, there's the height there. From the base, right, that's also the length over there. So you can use this measurement here, or you can use that measurement there. Should be the same, okay? And then I come along here on my turning point, and I go and add the height. Okay, now I can go ahead and add those together. Right, well, I mean join them, not add, join them together. There it is. Right, page is really smudgy today using this sort of pencil crown. Right, just come back down here, going back up to the top, and then back down to 1 again. Okay, emphasize the seams. There we go, those seams. I'm rushing through now. You don't show a false seam for the turning point, so leave that. And then obviously along the bottom, that's going to be the base edge in a straight line. There we go, there's your development of the branch pipe, as we would call it, but in this case the hexagonal duct. Okay guys, I hope this has helped you. A lot quicker, a little bit more rushed than I usually am when I do this, but it's just add to finish off the outline for the duct and the top and front view. There we go.